Hi everyone, today we are going to talk about ellipses. So let's start by talking about just the formal definition of an ellipse. So an ellipse is simply a set of points, so represented by this oval shape, where the sum of these two distances, the distance from your point to either focus, is always going to be constant. So d1 plus d2 is always going to be constant, no matter. So that means if I take a point over here and I add d1 plus d2, it will be the same as this plus this, which will be the same as this plus this. Now, a few more pieces of vocabulary over here. All ellipses have a center. They also have two foci. The longer length is always going to be called the major axis. Sometimes the major axis is horizontal, sometimes it's vertical, and the shorter length of your ellipse is always going to be called the minor axis. Your vertices are always going to be found at the ends of your major axis, but you can also find the two vertices at the end of your minor axis as well. All right, so let's look at what the standard of equation of an ellipse looks like. So like I said, sometimes you'll have a horizontal and sometimes you'll have a vertical ellipse. So notice there are a lot of similarities between the two. They both start with x minus h squared. They both continue with y minus k squared. They both equal 1. The only thing that's changing between the two is where a and b are. So the way that you're going to differentiate between the horizontal and the vertical ellipses is by looking at where your larger denominator is. So a is always going to be the larger value. If your larger value is under your x, we are going to have a horizontal ellipse. If your larger value is under the y, we're going to have a vertical ellipse. So that's how you determine which type of ellipse. I also want to point out that these two values are a squared and b squared. So to find a and b, you're going to need to take the square root. Now, here you can see in the picture what those a and b values represent. HK, just like the vertex of a parabola, is the center of our ellipse. A is always going to be half the distance of your major axis, or you could say that your major axis is 2a. And B is always going to be half the distance of your minor axis. So this from here to here is A, from here to here is A, from here to here is B, here to here is B. You can see in the picture that the distance from the center to the focus is going to be C. But maybe you're wondering, well, where does C come from? It's not in my equations. So there's actually a formula for this, and you can find C by using the formula C squared equals A squared minus B squared. Now make sure you keep this straight because you're going to see when we start talking about hyperbolas, the formula to find that C value is very, very similar but a little bit different. So it's A squared minus B squared. So that's how you use all those different aspects. I would always start with the center and then go to the right A, to the left A, up B, down B, and then right C, left C. Or the exact opposite if you have a vertical ellipse. Okay, so let's start by creating the standard form of the equation of the ellipse with foci at 0, 1, and 4, 1, and the major axis with a length of 6. So let's start just by drawing a little sketch of what we have going on. So if we have foci at 0, 1, and 4, 1, that means our foci are here and here. So I'm going to label them F for foci. So we know that the center of our ellipse should be in the exact middle of our two foci. And I can see that the exact middle of 0, 1, and 4, 1 should be right here at 2, 1. So this is going to be our center, and we can use that to find H and K. So we know that H is 2, and we know that K is 1. Now, if you look at what our formula looks like, it's going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. And I know that this is going to be a horizontal ellipse because I can see that my foci are lined up horizontally. So I already have H, I already have K. We do need to find A and B. So to find A, well, that's easy because they give us the length of the major axis. So the total length is 6, which means that our A value is going to be half of that, which is 3. So you might notice that we still need to find our B value, but they don't tell us anything about the length of the minor axis. However, what we can see here is that we know that this C value is going to be the distance from our focus to the center. And I can see that our C value is going to be 2. So we can use the formula that we know. We can say C squared equals A squared minus B squared to help us find B. So I'm going to substitute what we know. We know that this is 4 equals 9 minus B squared, so we can see that B is going to be the square root of 5. So now I have all of the different characteristics that we need to make our equation. We have H, K, A, and B, and now we just have to plug it in. So we have x minus 2 squared over 9 plus y minus 1 squared over 5 equals 1. And that is the standard form. All right, go ahead and pause the video and give this problem a try. Okay, so here we are given the foci, and here we can see that because the foci line up vertically, that is going to be a vertical ellipse, which means that our A value is going to be under the Y term. So once again, from the information we're given, we know that A is 4, we know that C is 3. We could find our center because it's exactly halfway between our two foci, and then we can use this formula to help us find B. Then you just have to plug it into the formula and you should be good to go. Notice once again that since it is a vertical ellipse, our A value should be underneath the Y term. All right, now let's try sketching an ellipse given the equation 4x squared plus y squared equals 36. And then we're going to identify the center and the vertices. So here we can see that our equation is not exactly in standard form, but we can really easily put it into standard form by dividing both sides by 36. So we actually will get x squared over 9 plus y squared over 36 equals 1. So from here, I can see that our center is going to be at 0, 0. I can see that our A value is 6 and that our B value is 3. I can also see, since the Y term has the larger denominator, that this is going to be a vertical ellipse. So when we go to sketch it out, here's our center. And then we would go up 6 and down 6, and then to the right 3, and then to the left 3. And this is what our ellipse looks like. So our vertices are going to be at 0, 6, 0, negative 6, and our minor axis vertices are going to be at 3, 0, and negative 3, 0. All right, go ahead and pause the video and give this one a try. Okay, so here you can see that our larger denominator is underneath the x term once we've rewritten it in standard form. So this tells us it's going to be a horizontal ellipse. Our A value is 9, so you start at your center and you go to the right 9 and to the left 9. Our B value is 3, so you go back to your center and you go up 3 and down 3. And that's a quick sketch of your ellipse. All right, so now we are given an equation that is clearly not in standard form, and they would like us to sketch it and also find the center, the vertices, and the foci. So we know that in order for us to create those binomial squared, we have to create x minus h squared and y minus k squared. So we're actually going to need to complete the square twice. We're going to need to do it one time for x and one time for y. So first thing I'm going to do is I'm going to group together my x terms And then I'm also going to group together my y terms. And I'm going to write it like this. X squared plus 6x plus blank, and then plus. Now, when I group together my y terms, I know that when I'm completing the square, I can't have a coefficient other than 1 for y squared. So I'm also going to be factoring out the 4 at the same time. And then we have y minus 2y plus something. And I'm going to move that -9 to the other side. So we have to complete the square here twice. So if we use our formula b over 2 squared, 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9 to both sides. And then for our y term, I'm sorry, we should have y squared right here. The number that completes our square is going to be +1. Now, I know it looks like we're adding 1, but actually we are adding 1 inside a set of parentheses that is actually being multiplied by 4. So while it looks like we are adding 1, we are actually adding 4 times 1. So we're actually adding 4. So notice on this side I added 4. So now we can factor each trinomial. Be careful, this one becomes y minus 1 squared. And then on the right side, -9 plus 9 plus 4 equals 4. And then to finish putting it in standard form, we're going to divide both sides by 4. And this is the standard form that we are going to graph and find all of the information for. So here I can see that our center is going to be at -3, 1. I can see that it's going to be a horizontal ellipse because the larger denominator is under our x term. I can see that our a value is 2 and that our b value is 1. Let's also take a second and let's find that c value. C squared equals a squared minus b squared. So c is going to be the square root of 3. So let's go ahead and sketch this and then find our vertices and foci. So this is just a really, really rough sketch. Here's 3, 1, so this is our center. I know that we're going to go to the right 2 and to the left 2. Those are going to be our vertices. And then we go up 1 and down 1. And we know that our ellipse is going to look something like this. Now, to find our foci, I can see that our foci are going to be to the right and to the left of our center. So that means that I'm going to take the c value and I'm going to add or subtract it to the x value. So our foci are going to be at -3 plus √3, comma, 1, and -3 minus √3, 1. And those values are going to be right around here and here. So now we have all of the information for a graph. We can also, let's actually take a second and label the vertices as well. We can see that we have vertices at -5, 1, -1, 1, -3, 2, and -3, 0. So there you have it. So just remember, when we are completing the square, one of the really important things you need to watch out for when you're rewriting in standard form is if you have a factor out front, which changes what you're actually adding to both sides. And then just go through the process and make sure you can find A, B, and C to find all of the characteristics that you need. All right, go ahead and pause video and give this problem a try. Okay, for this problem, once again, we have to complete the square twice. When we complete the square for our x trinomial, we're actually adding 36 to both sides, and when we complete the square for our y, we're actually adding 4. And then when we set our equation equal to 1, we should end up with x plus 2 squared over 4 plus y minus 1 squared over 9 equals 1. Since the larger number is under y, I know that our ellipse is vertical. Our center is at -2, 1. Our a value is 3, b value is 2, and our C value is going to be root 5 when you use the formula. So since our ellipse is vertical, that means that we're going to start at the center and we're going to add or subtract our C value from the Y. That's how we got 1 plus or minus root 5. And then for our A value, we're also going to add or subtract that to the Y. That's how we got negative 2, 4, and negative 2, negative 2. And for the B value, since it's under the X, we're going to take that and add or subtract it from the X. That's how we got the vertices 0, 1, and negative 4, 1. Okay, let's try one more example together. So here we have to go through the same process of grouping our terms and factoring out any coefficient. So when we do that, here we have 4 times x squared minus 2x plus some magic number plus y squared plus 4y plus some magic number is going to equal 8. So I can see that the number that's going to complete the square for this trinomial is 4, but we're 1, but we're actually adding 4, and then for this value is 4, and we are actually adding 4. So we end up with 4 times x minus 1 squared plus y plus 2 squared equals 16, and then put it into standard form by dividing both sides by 16. Okay, so from here, I can see that our center is going to be at 1, negative 2. I can see that this is going to be a vertical ellipse because the larger number is under the y. I can see that our A value is going to be 4, B is going to be 2, and our C value is going to be the square root of 12, which is 2 root 3. Now, let's try to find the foci without sketching a graph. So for our foci, I know that since our ellipse is vertical, they're going to be above and below, which means that we start at our center and we're actually going to add or subtract 2 root 3 to our y value, which would move us up and down. So our foci are actually at 1, negative 2, plus or minus 2 root 3. Those are the foci. Since our A value is 4, I'm going to be adding that to the y. So once again, go back to your center, and then we're going to add or subtract 4 to find our other 2 vertices. So we should have 1, negative 6, and then 1, 2. And we can even find our minor axis vertices as well. Go back to your center, and then we're going to add or subtract b from our x value. And you can look back at your equation. The b value comes from right underneath your x value. So this will give us 3, negative 2, and negative 1, negative 2. So those are the 4 vertices of our ellipse. Okay, last problem. Go ahead and pause the video and give this one a try. Okay, once again, you have to go through the process of completing that square. Your standard form should end up being x plus 1 squared over 9 plus y minus 3 squared over 5 equals 1. I see that it is a horizontal ellipse. A is 3, B is root 5, and C is 2. So our center is at negative 1, 3. Our foci are going to be to the left and right because it's horizontal. So I take the C value and I add or subtract it to y. So that's how we got 1, 3, and negative 2, and negative 3, 3. And then our vertices can be found by adding or subtracting the A and B values from x and y as well. Okay, that is all for today's video. Thank you so much for watching.